your turn.
Okay. Hello, everybody. My name is En Haixia, and I'm a master student of computer science major. And this is my second year to study this major. And currently, I'm working as a data analyst and now need to deal with the data to predict the marketing trends every day. So this is the reason why I choose this course. I want to learn more data process techniques, which can help me in my work. And today I will talk about the Naya, and it's a preventive and adaptive fire mitigation service. So today I'm going to talk about it in 4 parts. The first part is what is Naya and why did they create Naya, and how does the Naya work, and what is Naya's limitation. So what is Naya? From the previous video, we can know Naya is a fire mitigation service for cloud system like the Microsoft Azure. And Naya predicts imminent host fires based on the multi-layer system signals and provides smarter mitigation actions. The design goal of Naya is to prevent virtual machine fires ahead of time and enhance their self-managing capability. And Naya has been running on the Microsoft Azure for 15 months and gave a good result of stopping the virtual machine interruption by 26%. So the next is where this idea come from, why they need to make the Naya service. And we can discuss for this to get answer in 2 questions. And the first one is once a fire happens, how to quickly detect and mitigate it so the system can continue running. If you use any kind of application system or web services, you must have the experiences of fire. When the fire happens, it will cause the system running slow or totally shut down. Then the technicians need to detect and fix the issues quickly. But during the time of detecting the mitigation, that will make users have bad experiences. The system should keep running without any interruption. That's ideally. Then we can give the users have a good experiences. And also current fire mitigation is a reactive and ad hoc way. Take some fixed actions only after a server's symptom is observed. That is hard for large cloud platform to implement. And many, because at that time, at the same time, millions users are running the virtual machine at the platform. So only improving post-fire detection is not enough. We need a service which can predict the coming fire and fix it before it happens. And moreover, the cloud system is constantly changing, like software and hardware updates and the customer workflow changes. So some mitigation actions that work well in the past, but may not fit for the future issues. And we want a service can learn it by itself and can do the live migrating the virtual machines from the node predicted to fail to a health node. So from all these challenges, we can get the goal for Naya. The authors developed the Naya system, which can predict whether a host environment might fail soon, and automatically decided on mitigation plan among multiple choices, and it can avoid future virtual machine failure events. So next, we're gonna see how Naya works. This is the workflow of Naya. you can see it have four parts: the monitoring, prediction, designing, and mitigations. So next, I'm gonna introduce the four parts one by one. And the first part is monitoring. Monitoring is to get the signals from like the platform. Each node in Other Microsoft Other is deployed with monitoring agent that collects all signals about the host environment. And the second one is a protection part. Protection part in Naya will continue to consume these signals and predict whether a node will fail soon. And the protection is made through static domain rules and running machine learning inferences. Stream each protection result into Naya's decision part as a mitigation request, and the Naya supports two decision-making methods, which is right here is A/B testing and Brandeis. And the decision-making components calculates the probability distribution of the selection of applicable mitigation measure and then selects a good one for the distribution. And the last part is the mitigation controller. The mitigation controller applies the selected mitigation operation to suspicious node. And the whole process is an automatic feedback loop, which can optimize the key target in inductor. Which the key target inductor is a virtual machine interruption rate. Naya observes the effects of mitigation measure and adjusts future forecasts and mitigation decisions based on observations during production. So next, we're going to see some details about the four components. The first part is input signals. Naya connects signals from host environment to make sure informed prediction. For hardware and firmware and the monitors agent collect low-level logs from disk smart attributes, memories, CPUs, and the motherboard. A higher level source of signals come from device drivers. For example, is timeout events. And the second important source of signal are result from the control plan operations. For example, repetitive virtual machine creation operation errors could index a series host issues even if the host still appears to be running. Then the second part is prediction, which includes two resources, the rule-based prediction and the learning-based prediction. The rule-based prediction works best for definitive signals that index some issues with high confidence. Since many familiar signals are not definitive, rule-based predictions cannot cover a wide range of impending failures, and the forecast may be delayed and may not provide the right lead time for the interrogation engine. And the number of forecasting rules is also increasing, which become a burden of management and adjustment. So to address the limitation of rule-based prediction, Naya used additional learning-based predictor that analyze more signals and patterns in larger time window. It can predict many complex host failures. It can also make predictions earlier and leaving longer time for mitigation engine to react. The third part I'm going to talk about is mitigation actions. The mitigation actions have several possible actions. From the paper, we can know the first one is live migration, moves a running virtual machine from one host to another with many disruptions. And the second one is a virtual machine preserving software reboot, which preserves the virtual machine state across the reboot of the host OS. Then the next one is service hanging. Is used to restore the service vulnerabilities of unhealthy or faulted virtual machines. And then is the mark unallocatable that can block allocation of new virtual machines to a host for sometimes, and the default time is 7 days. The next is avoid. Avoid informs the unlocker to try avoid adding new virtual machines on the host. The last one is a no OP. It's a special action for predict failures in which the controller does not take any actions. And then the last part of the Naya is the decision logic for adaptive mitigation. They have two ways to choose which mitigation actions they need to take. And the first way is A/B testing. As the picture showed, A/B testing is working like this way. You have two options, the option one and option A and option B, and give different option, different testers, and then get the result. You choose a better one. So the Naya is working like each predictor node is assigned to different action groups with equal probability. And after taking each action, they measure the customer impact within an observation window. And they use the testing. They use the if action yields significantly less customer impact than other, so they can choose that one. So once the statistical significance is reached, they consider the listing impact action optimal to apply it for all nodes. And they keep monitoring the customer impact per node for the used action. And then if customer impact significantly increase, they run a new A/B testing in experiments to do the actions again and again to find the good optimal. But they have some limitation of the A/B testing, which is the group assignment. It's only can use the on static group assignment. So in order to leverage the estimated differences between the groups to minimize the cost, to minimize the customer impact over time by ensuring a balance between exploring potential better actions and promoting the discovered best action. So they use the blended modeling. And the last part, I'm going to talk about the challenges of the Naya. The first part is acting with incomplete information. Failure mitigation has to act with incomplete information since the underlying root cause is not known. For Naya, this challenge is even more pricing since the failure has not happened yet. And the second one is too many factors to consider in the decision logic. Due to the massive scale of a cloud system, there are many factors to consider in the decision logic. A decision may work well for some nodes, but not for others. The third one is false positive are unavoidable. When when the system is doing failure prediction into a production cloud system, false positives are unavoidable due to the complex system environment and large numbers of noisy signals, unexpected customer workflows, and the other issues.